as part of the Big Bang UK Young Scientists and Engineers competition and as part of the Young Engineer for Britain competition, I was developing and manufacturing a device to improve the efficiency of data manipulation in the manufacturing industry. So we were looking at taking real-time information and displaying it and storing it for future use on a single device. Because one of the issues at the moment, especially in the automotive industry, is that there are lots of complex control systems, but companies are chartering out private organisations to come and fix them if something goes wrong. So as a student, I was looking to maybe start off with an open source single device which you could add modules to, very similar to the Arduino concept, the Raspberry Pi concept, but making it a little bit more user friendly and trying to remove the complexity of signal processing and basic code and that sort of thing. And it really took off. I entered it into the Big Bang and Young Engineers, and it taught me a lot about not only how to manufacture a product, but how to problem solve all manner of electronic issues, from not setting registers correctly on chips to fixing short circuits. One of the issues I had was, it's a simple electronics concept, is a matrix. So I was using a digital keypad to try and get some sort of input from a user, but one of the main things we had the problem with is that I was creating a code and a looping procedure to check columns and rows, but for some reason I wasn't getting any input at all. So I was like, well, what's going on here? Is it a problem with the mathematics of the code? Is it a hardware issue? Something as simple, it's a dry joint on one of the PCB sockets. So, it's about something as simple as that you wouldn't learn unless you've got the experience of it. So I started off with pickaxe chips, so common in educational institutions for teaching younger students how to program in BASIC and how to interface microcontrollers. So it taught me a lot about the concepts of serial communication and digital inputs and outputs, but also how to take analog inputs and convert them into digital signals so that you can control outputs like motors and things like that. So I've got a keen interest in embedded systems, but specifically in the aerospace industry. So I want to look into it's a manufacturing technique that's coming into the modern world now. Is it's three-dimensional printing of PCBs and circuits by using metal powders. So before we've had very linear PCB boards that take up a lot of space and you stick these onto aircraft, but a new modern technique is to be able to use copper powders and polymer residues to be able to create three-dimensional circuits into the structure of the aircraft itself. So not only are you taking away the weight, you're reducing material cost, and also you haven't got the big problem of making casing and protective circuits because it's part of the actual infrastructure of the aircraft itself. So I think going into university, that's something I'd definitely like to research and be part of. I think it's something that's different for every student. I think that something that gets you interested into technology and design, you can't really pin down on the exact thing that it will be for a certain person, but you can take advantage of common techniques of introducing, here's an assembly to a load of students of this is something that someone else has done, but I think it's about finding something that children can relate to. And I think it's important to try and get the younger generations who have experience, like myself, like other young engineers who have gone and done it themselves, to be able to take their passion and their interests and sort of imprint that onto the younger generations. From my perspective, I was very interested in physics and chemistry, and I never really was interested in electronics or computer science anyway. So that came about for me going into GCSEs, and I think that's a very critical time for younger generations. And especially in the modern world where it's so easy to go and buy electronic kits. I mean, like RS, you've got so many. You've got the Raspberry Pi, you've got the Arduino, you've got the BBC Microbit. You can go and purchase these things off the shelf. So maybe making that a mandatory part of school curriculum might be an interesting way of generating more graduates in the future as well.